This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 6, Lesson 11, the Supportive Knowledge Capstone, and the finale of the whole HVAC-R course. No new formulas. Everything you built across controls, system types, codes, acoustics and vibration, piping, humidification, and combustion comes together here. We'll work 4 exam-style problems: a DHW recirculation loop, a vibration isolator, a ventilation rate, and a control valve. Then consolidate the week's traps and close the course. The route map. Week 6 is the most cross-chapter week, so name the topic first. That alone picks the chapter and the equation. A DHW recirculation question routes to the pump capacity formula in the piping section, an isolator to the natural frequency relation, a ventilation rate to the breathing zone formula, a control valve to its flow coefficient, then a separate cavitation check, and the concept traps, combining sound levels, mixed air temperature, percent theoretical air, each have a printed home too. Problem 1. Piping. Recirculation pump capacity is the piping heat loss over 500 times the allowable temperature drop, 9 GPM. Then the L bend, 6.225 times the root of expansion times outside diameter, 16.2 feet. Watch the units. Expansion and diameter go in as inches, but the leg length comes out in feet. Problem 2. A spring isolated fan. Natural frequency comes from the printed circular frequency, root of G over static deflection divided by 2 pi, a little over 3 Hz. The fan turns at about 29 Hz, so the frequency ratio is well above root 2 and the fan is isolated. The trap, a stiffer mount with less deflection, raises the natural frequency and makes isolation worse. Bigger deflection, lower natural frequency, better isolation. Problem 3. An office ventilation rate under 62.1. Breathing zone outdoor air is the people rate times occupancy plus the area rate times floor area. 250 plus 300, 550 CFM. Keep both terms. Dropping the per area piece is the miss. Problem 4. A chilled water control valve. Size it with the flow coefficient, flow over root of the pressure drop, a flow coefficient of 20. Then a separate check. The allowable cavitation drop is the recovery factor times inlet minus vapor pressure, about 35 psi, well above the 4 psi design drop, so no cavitation. Sizing and cavitation are 2 different formulas, don't conflate them. The whole week's traps in one screen. The L-bend formula takes inches in and gives feet out. Sizing flow coefficient versus the cavitation pressure drop, different formulas. Bigger static deflection lowers the natural frequency and improves isolation once the frequency ratio passes root 2. 2 equal sound sources add 3 decibels, not 6. Percent theoretical air is 100 points above percent excess air. Don't swap them. Mixed air is flow weighted, never a plain average, and the economizer high limit is dry bulb or enthalpy. Know which one the question names. Look up discipline. Don't hunt Chapter 11 for numbers. It holds the controls vocabulary, but the equations live elsewhere. Economics and motor electrical are Chapter 1. Isolation physics is Chapter 2. Motor heat gain, acoustics, central plant components, mixed air and changeover temperatures, and the ventilation tables are in Chapter 9. The refrigerant safety table is in Chapter 8, and combustion lives in its own Chapter 10. Know which chapter owns the topic, jump to it, and confirm. The method under time. Name the topic first: motor, isolator, ventilation, valve, economizer, or payback, because that selects your chapter and your equation. Read the pill, confirm the printed form, and substitute. Don't rebuild a formula from memory. Then watch the units. Deflection in inches pairs with G in inch units. Cavitation pressures are absolute, and ventilation carries both a per person and a per area term. If a property isn't printed, the problem gives it to you. That's a wrap on Week 6 and the entire 6-week HVAC-R course. Psychrometrics and loads, airside distribution, refrigerants and the vapor compression cycle, air quality and comfort, the water side and central plant, And now controls, system types, codes, acoustics and vibration, piping, humidification, combustion, and the supportive knowledge that ties a building together. That's the whole HVAC body of knowledge, mapped to the handbook you'll carry into the exam. Everything's at PEPrepEngine.com. A cheat sheet, work solutions, and a quiz are attached here. If the course helped, please subscribe, and good luck on exam day.
The full study guide with every equation and common exam trap is free at PEPrepEngine.com, link in the description. Structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.